good example. If x power n plus 2, x power n plus 3, y power n plus 2, y power n plus 3, z power n plus 2, z power n plus 3 is equal to, determinant of this one is equal to x minus y minus z minus x into 1 by x plus 1 by y plus 1 by z. Then find the value of this n. See, according to degrees, if you observe here, what is this degree? 1, 1, 1. This degree is minus 1. Yes, 1 by x means x power minus 1, y power minus 1, z power minus 1. Degree is minus 1. So what is this? 1 plus 1 plus 1 minus 1. So degrees, if you go for according to comparing degrees. So total this one is degree is here 1 plus 1 plus 1 minus 1. For this degree, n plus n plus 2 plus n plus 3. Go to always principal diagonal. Okay, n plus 2 plus n plus 3. Total how much? N plus 1. 3n plus 5 is equal to 2. So 3n plus 5 is equal to 2 means 3n is equal to 2 minus 5, that is equal to minus 3. So n is equal to minus 1. This is the answer according to degrees. Very, very important model. Next, these are the problems in our book. Okay, find determinant of 1 omega. This is called omega. Okay, not w. Omega, whenever you have omega, you just remember these two formulas. Actually, these two will come in second year complex numbers until you just remember 1 plus omega square is equal to 0 and omega cube is equal to 1. These are the two important identities. You just remember. Okay, so find this value. See here, according, if you know this one, 1 plus omega square is equal to 0, our problem will be very easy. See here 1 omega square. If you go to operate either column operation or row operation, anyone you can use here, no problem. See, if you use the row operation means R1 implies R1 plus R2 plus R3, or R2 implies R1 plus R2 plus R3, or R3 implies R1 plus R2 plus R3. Anyone you can operate, no problem. You get same value. If you use R1 implies R1 plus R2 plus R3, if you know for this one, 1 plus omega square is equal to 0, then that row all zeros you get. See here. So R1 implies R1 plus R2 plus R3 means R1 is going to change. You have to use R2 and R3 added to R1. So 1 plus omega square. Only R1 is going to change. So right here. And second elements. Omega plus omega square plus 1. That is also 1 plus omega square only. And omega square plus 1 plus omega. That is also 1 plus omega square. Right in the first row. And second and third rows right as it is like. See here 1 plus omega square 0. 1 plus omega square 0. 1 plus omega square 0. And write second row and third row as it is. So if all entries are zeros in any row or column, the determinant is equal to 0. If we expand this one, 0 into anything is 0, 0 into anything is 0, 0 into anything is 0. So totally you get 0. So that's why that value is also 0. Next, second question. Find the determinant of 0, p minus e minus r, e minus p, 0, r minus p, r minus e, p minus r, 0. See here, all diagonal elements are zeros. Once if you observe all diagonal elements are zeros, then you have to check once, is it a skew symmetric or not, and it is order or not. It's because of the determinant of skew symmetric matrix of odd order is always 0. So once you check it out, so that means if all are zeros are there, then you have to verify for skew symmetric means these two are in opposite sign or not, these two are in opposite sign or not, these two are opposite sign or not, but magnitudes are equal. Okay, it is e minus b, this is p minus e. If you take minus common, it is also minus of e minus b, then it is e minus b, it is minus of e minus b. It is r minus e, it is of minus of r minus e. It is p minus r, it is of minus of r minus p minus r. P minus r minus of p minus r. This is also, if you take minus common, here also minus common, here also minus common. Yes, it is a skew symmetric matrix of odd order 3 by 3. So then this determinant is always 0. No need to expand. Next one. Find the determinant of a minus p, p minus q, x minus y, b minus c, q minus r, y minus z. C minus A, R minus B, Z minus X. Once you check it out, first of all, here like that A minus B, B minus C, C minus A, like that if you have, first you have to verify for, if you add them all, if you add all, you get 0 or not. Once you check it out. If you operate the column operation, C1 implies C1 plus C2 plus C3. It is A minus B, it is B minus Q, it is X minus Y. So if you add, you never get B0. But according to row operation, if you add, what you get? A minus B, B minus C, C minus A. Add them. So A minus B plus B minus C plus C minus A, minus B plus B minus C plus C cancel, plus A minus A also cancel, 0. Similarly, P minus Q, Q minus R, R minus P. Q, Q, R, R get cancel, and P, P also cancel. Same, Y, Y, Z, Z, X, X also cancel. So go for R1 implies R1 plus R2 plus R3. So what you have, so just now explained. So these 3 add, then use 0 and you write in the R1 place 0, 0, 0. So and write second and third rows as it is. So this all are zeros, then the determinant is equal to 0. Very clear answer. Next, fourth question. Find 1 BC A into B plus C, 1 CA B into C plus A, 1 AB C into A plus B. Find this determinant. So already I told you, if all are ones, then you go for making at least 2 elements are zeros. But before that, if you have any expansion in that any row or column, that means if it has 2 terms, okay, 2 terms, 3 terms, like that, then you have to expand it. That is one way. And another way is, if you expand without expanding, if you add all the, for suppose any 2 columns or 2 rows, then if you get all entries are equal to some fixed number, then you can take outside that fixed number. That is also one way to do the problem, okay, without making these 2 zeros. Okay, see here, once you observe, it is what here? AB plus AC. This is BC plus CA. This is CA plus AB. Okay, if you BC, CA, AB add to this column, or this column is added to second column, then all of them are equal to fixed number, that is AB plus BC plus CA. Once you check it out, this is BC plus AB plus AC. This is CA plus BC plus BA. This is AB plus CA plus AB. That means if you write in the order, all of them are nothing but AB plus BC plus CA. Once you check it out. Okay. So then all of them are equal to a fixed number in any particular row or column, then you can take outside. After that, if all are ones, you get, after taking outside all entries in that row or column, you get ones. So here also ones, here also ones if you get. So 2 rows or 2 columns are identical, then the determinant is equal to 0. Once you go for procedure, then you can understand easily. So first you expand this one, AB plus AC, BC plus CA, CA plus AB. First you do this one. So now add C2 implies C2 plus C3. So you add this one, BC, AB, AC, CA, BC, BA, AB, CA, CB. All are equal. AB means AB. Here AB is there. Here also AB is there. BC, 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 AC, AC, AC. So all are fixed numbers. So C2 implies C2 plus C3. So this is equal to 1 AB plus BC plus CA. 1, that means 1, 1, 1, AB plus BC plus CA, AB plus BC plus CA, AB plus BC plus CA, and third column as it is you write. Otherwise you write this one also, no problem. I written first one only what I have. Okay, so no problem. So now you take this AB plus BC plus CA outside. So this is 1, 1, 1 after taking AB plus BC plus CA outside. So second column also all are equal to 1, and this is right as it is. Now these 2 columns are identical, same. Corresponding entries are equal, then those 2 columns are identical. If 2 columns are identical in the matrix, then the determinant is equal to 0 in the 3 by 3 order. So next question, if alpha, beta, gamma are the roots of xq plus bx plus q is equal to 0, then find alpha, beta, gamma, beta, determinant of alpha, beta, gamma, alpha, gamma, alpha, beta. You just remember one thing already you have in 10th class, polynomials. X cube plus px plus q is equal to 0 means here x square term is 0. Okay, and alpha, beta, gamma are the roots of this third degree equation. So then sum of these roots alpha plus beta plus gamma is equal to 0 because of if you first I am giving the formula once again. It just remember alpha, beta, gamma are the roots of ax cube plus bx square plus cx plus d is equal to 0. Then alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. Use this one. Here alpha, beta, gamma, the roots of x cube plus px plus q is equal to 0. Then sum of the roots is equal to 0 because x square term is not there. And sum of alpha, beta plus beta, gamma plus gamma alpha is equal to that is plus po that gives. And alpha, beta, gamma product is equal to minus q by 1 that is minus 2. But those two are not used to do this problem. So only alpha plus beta plus gamma is equal to 0 just use because of here. If you go for any row or column, if you add all the entries, you get alpha plus beta plus gamma only. That value becomes to 0. So total determinant also 0. See here, if you go for either column operation or row operation, both give same answer here. So I use here column operation C1m plus C2, C1 plus C2 plus C3. So what you have alpha plus beta plus gamma, beta plus gamma plus alpha. That is also alpha plus beta plus gamma only. Gamma plus alpha plus beta. That is also alpha plus beta plus gamma only. So beta, gamma, alpha, beta. Okay, so these all entries are zeros based on this concept. So zeros, if in a row or column all entries are zeros, then determinant is equal to 0. Next question, find determinant of 1 log y base x, log z base x, log x base y, 1 log z base y, log x base z, log y base z, 1. See, you just use this formula in logarithms. All SSC students, they know very well about the logarithms, but CBSE, I think so, they don't have logarithms. But you just remember this formula. How to call the logarithm also important. This you call log a to the base b. Base should be at this curve, and this domain should be at this top. This you call the domain. Log a to the base b. Log a to the base b. Log a to the base b. Okay. Now this is log y to the base x is equal to log y by log x with any common base. Actually, logarithm always should have base, but nothing there means here either 10 or e is there. Here maybe base 10, both are 10s or both are e's. Okay, no problem. So without writing, then you can understand both have the same bases. So you can write log y to the base x is equal to log y by log x. Okay, so use that formula to expand this one. See here, same I have written the given determinant. So now I have written this one you can write as log x by log x because of in this row all bases are x's only. Just you I have written this one in terms of log x by log x. This is log y by log x. This is log z by log x. This row. This is log x by log y. So because of in this row all bases are y only, so this one I can write as log y by log y. This one log z by log y, log x by log z, log y by log z. This is log z by log z. This is equal to 1. Here you understand in this denominator 1 by log x is there. That means log x is there. That 1 by log x you take outside. In this log y is there, 1 by log y take outside. In this log z is there, 1 by log z take outside. Now you have log x, log x, log x. This is log y, log y, log y. This is log z, log z, log z. Okay, again this log x also take outside. This log y also take outside. This log z also take outside. Right in the numerator. So log x, log y, log z by log x, log y, log z. 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so at least two rows are identical or two columns are identical, then determinant is equal to 0. Here all are identical, so determinant is also equal to 0. Okay, one based on one complex numbers. If 6i minus 3i 1 4 3i minus 1 23i is equal to x plus iy, then find the values of xy. Here you just understand I is equal to root over minus 1 iota. Already you know in physics I square is equal to minus 1. Like these problems, you cannot operate that means row or column operations directly, you expand it. So 6i into leave the row and column minus 3i, sorry, 6i into leave the row and column 3i into I 3i square minus of minus 3. Okay, that means plus 3. Next minus into minus plus 3i into leave the row and column passing through this one. So we have 4i minus of minus 20, that gives plus 20. Next plus 1 into leave the round column passing with this one. 4 3 is 12 minus 20 into 3i, that is 60i is equal to the given x plus iy. Simplify, I square is equal to minus 1, that is 3 into minus 1. 6i into 3 into minus 1 plus 3 plus directly with 3i multiplied inside, 3i into 4i, 12i square plus 23 is 60i plus 12 minus 60i is equal to x plus y. Minus 60i plus 60i cancel, and here I square is equal to minus 1. So here this is minus 3 plus 3 0, 0 into anything is 0. Here you have 12 into minus 1, that is minus 12. Here we have one more 12, that is plus 12 is equal to x plus iy. So this is gives 0, total gives 0, 0 is equal to x plus iy. So you should write this 0 in terms of x plus iy. How can you write 0 plus I0? So if you compare this corresponding real and imaginary, then what you have, x is equal to 0, y is equal to 0. So this is a real part, this is imaginary parts. So x is equal to 0, y is equal to 0. That is he is asked to find out. Okay, remaining problems you see in next video. Okay, I think so all the problems we can do in same manner.